Good evening, sir.
Yes, good evening. Am I audible?
Yes, sir, you are audible, sir.
Okay, all right. Just wait for 5 minutes. I'll start. Yeah.
Sure, sir.
So very good evening to one all present here. So this is Professor Assistant Professor Jeremy from the Department of Cybersecurity, SRM Institute of Science and Technology, Ramapuram. It actually gives me immense pleasure to welcome you all to the second day of the one-week national level faculty development program on next generation cybersecurity and ethical hacking. Yesterday marked a wonderful beginning with insightful discussions and enthusiastic participation, and we look forward to another enriching learning experience today. First and foremost, I would like to extend a warm and respectful welcome to our head of the Department of Cybersecurity, Dr. J. Jagdish Tamil Selvi ma'am, whose continuous encouragement and guidance play a vital role in organizing academic initiatives like this FDP that strengthen knowledge and professional growth. It is also my privilege to warmly welcome our esteemed resource person of the day, Dr. Jagdish Pimple, Assistant Professor from St. Vincent Pallotti College of Engineering and Technology, Nagpur, Maharashtra. Welcome, sir. We are
Thank you, madam.
truly
Thank you.
grateful. We are truly grateful to have you with us today to share your expertise and insights in the rapidly evolving domain of cybersecurity and ethical hacking. I would also like to extend my heartfelt welcome to all the faculty members and participants who have joined this program from various institutions. Your active participation and interest make this FDP a meaningful platform for knowledge exchange and collaborative learning. A special welcome to all the coordinators belonging to the SKRGC Academy. Cybersecurity has become one of the most critical areas in today's digital era. As technology advances, the need for stronger security frameworks and ethical hacking practices becomes even more essential. Programs like this FDP help educators and professionals stay updated with these latest trends, tools, and techniques to address emerging cyber threats. Once again, I warmly welcome our distinguished speaker, respected faculty members, and enthusiastic participants to the day 2 session of this national level faculty development program. I hope today's session will be highly informative, interactive, and inspiring for all of us. Thank you all, and I wish everyone a productive and engaging session ahead. Now, I welcome Ms. Humani M, Assistant Professor, Department of Cybersecurity, to introduce our guest.
Good evening, everyone. Dr. Jagdish F. Pimple is an experienced academician and researcher with an 18 plus years of experience in the field of information technology and computer science. Currently, he is working as an assistant professor in the Department of Information Technology at St. Vincent Pallotti College of Engineering and Technology, Nagpur. He previously served as HOD IT Department at Nagpur Institute of Technology, Nagpur. He has a bachelor degree in computer technology and an MTech in software engineering and a PhD in computer science and engineering. His research interests include blockchain technology, artificial intelligence, machine learning, cybersecurity, cloud computing, and medical cyber physical systems. Dr. Pimple has made significant contributions to research and innovation with the 47 plus international journal publications, 20 international conference papers, 12 national conference papers, 7 patents, and 13 copyrights. He has authored 3 books and multiple Scopus Index book chapters with reputed publishers. He has delivered expert talks and FTP sessions on topics such as research paper writing, blockchain applications, programming skills, and cybersecurity, and has served as session chair, reviewer, and resource person in numerous international conferences and academic programs. Dr. Pimple has received several recognitions, including Best Performing Faculty, Best Researcher at Institution Level, and also recognized as a top mentor by NPTEL IIT Bombay. He is an active member of professional bodies including Computer Society of India, Institute of Engineers, and other international computing societies. His commitment to academic excellence, research innovation, and industry academia collaboration makes him a valuable contributor to multidisciplinary education and research initiatives. Welcome, sir. Welcome for the session, sir. Thank you.
Okay, thank you so much. Is it my voice is audible clearly?
Yes, sir. Audible,
Please let me
sir.
know. And my screen is also visible and moving. Please check. Screen is moving.
Yes, sir.
Yes, sir. Yes,
Yes,
sir.
sir. Yes.
Okay, all right, all right. First of all, thank you so much, SRM Institute of Science and Technology, Department of Cybersecurity for organizing faculty development program on next generation's cybersecurity and ethical hacking. I also thankful to the SKRGC Academy for providing me the opportunity for interacting for this particular faculty development program with the audience. Actually. One more thing I'll mention. So I'll extremely sorry as far as the schedule is concerned. Today's session was happened to be at 6 o'clock, but due to some technical glitch at my side, so we have started at 7 o'clock. So sorry from my side, right? Okay. So for the today's sessions, I have chosen a topic that blockchain-driven privacy for electronics health record, that is EHR. Moving towards the introduction part, the very first thing is why we have chosen this particular topic, that is blockchain in healthcare records. Right, we are going to manage the EHR with the help of blockchain. As far as the theme of the FDP is concerned, which is next gen cybersecurity and ethical hacking. Right, now talking about the hacking and the cybersecurity. So with this concern, the medical system or medical healthcare system, that is major concern about the securities of the data, which are what we can say, which are happening with the medical institutes or medical research institutes, or we can say hospitals as well. That's why I've chosen the topic that how we can use or how we can secure our hospital data, how we can secure our patient data in today's era actually. So now moving towards the introduction. So the very first thing is electronics health records, that we are going to store the patient records in data in digitally formats. Nowadays, what happened in a traditional systems, when we talked about hospitals, when we talked about any healthcare institutes, when we talked about the pathological labs, they all are maintaining the records in a traditional patterns. They are maintaining the records in a manual formats. They'll use papers for printing the reports, use the papers for preparing the prescriptions, and so on. So all of these traditional systems we need to think to convert into the digital format. So it means that we're going to create electronics health records for the patients or for the hospitals. While thinking on this particular things on EHR, there are a lot many challenges would be there. That one of the most major thing is privacy, security, and data integrity. Why privacy, security, and data integrity are placed the various most challenges for maintaining the electronics health record for the um, medical institutions or the hospitals. Because when we're talking about the data with respect to patients, with respect to doctors, and so the privacy and the security is a major concern, because when data get travel over on the network, the security and the privacy plays a vital role in case of hospitals, in case of a medical healthcare research institute as well. So how to overcome these challenges? So we need to take the help of blockchain technologies. As in today's era, everyone is talking about a blockchain, whether it is finance sector, whether it is healthcare sector, whether it is institutional educational institutions, whether it is finance sections. So lot many industries are moving towards the blockchain technology because it is well known for privacy and security purpose. So blockchain offers a decentralized security systems actually. So basically when we talked about the blockchain, so basically what it means the blockchain actually. First of all, I'll talk about the background and motivation for EHR, where the motivations come for this particular things. Why I have talked more about the patient record management system in a digital platforms. Just consider a scenario. Nowadays, what happens? Suppose if any patient is there, if any patient wants to take the treatment from any hospitals, so patient personally needs to visit the hospital, need to tell all the past history, present history about his diseases to the concerned doctors. Doctor will go through the complete information received from the patients, and according to that, doctor suggests some sort of a medical prescription. Doctor also suggests some sort of a medications. Doctor also suggests some sort of a test. And at last, the doctor will prepare one file, and that file is get overhanded to the patients. So whenever patients needs to visit the hospital, so every time he needs to carry that particular file. But suppose if the one particular patient is suffering with a different diseases, so what happens? So whenever he will visit to the different hospitals, because for the different disease, the different experts are there, right? So every time, suppose if I'm suffering with diabetes, if I'm suffering with some cardiologist, if I'm suffering with suppose kidney related issues, if I'm suffering with some eye related issues, so for every diseases, the experts doctors available, and we are going to visit the concerned doctors. So whenever we are going to visit the concerned one, so every hospital will hand over one file. So it is a very much overburden to each and every patient while moving to the hospitals here and there. So we need to keep the record of all of these files. So considering the example, suppose if I'm suffering with 5 diseases, so I need to carry my five files. And consider this consider one scenario. Suppose the file get lost during the traveling, say, or any other issues. Suppose my file get lost, so it is very much difficult for the patient as well as for a doctor. When I visit the hospitals without any file, so doctor is also confused, because doctor is also not remembering the what type of treatment that particular doctor has given to the patients previously, because many of the patients, the number of patients are visiting the hospitals, and for as far as the doctor is concerned, there is not possibilities at all that every doctor keep in his mind about the each and every patient's records, each and every patient information. It is not be possible. Then why we are not going to create or why we are not thinking for the we are going to create a digitalized system for the patient record. So the meaning is, if whatever patient is there, whenever he is moving from here and there, from city to city, from country to country, or anywhere else, so the patient record is available at a single platform. So if even though I'm changing the doctors, so on a single click, any doctor can see my previous history on a single click. Anytime the doctor can see on how many hospitals that particular patient has visited, and which doctor has provided which type of treatment to the concerned patients. Now what happen if I'm taking the treatment from one doctor, when I change the doctor, the new doctor will again start from the scratch. So it is very much difficult because the current doctor doesn't know what type of treatment or what type of medications had previous doctor has given to the concerned particular patient. It is very much difficult. And as far as the financial terms are concerned, because every doctor started from the scratch, that means starting from the taste, these and that things, right? So as far as the patient is concerned, it is very difficult for the patient, as well as doctor is concerned, it is very difficult for the doctors, right? So if we're thinking for that, we are going to create a platform, or we are going to create a EHR system, that is electronic health record. So the data of each and every patient is maintained digitally, and that too available on a single click, so that any doctor from any hospital, from any country, from any state, from any city can access a data on a single point, so that the doctor doesn't have to worry about that what type of treatment, what type of medications was given by the previous doctors. So that is a background and a motivation for this particular electronics health record system. Nowadays what happens, whenever we'll visit the doctors, so doctors will doctors or the concerned staff of a particular hospital prepare the file and hand over that file to the concerned patients. So nowadays manual system is there. Again, if we talked about some of the hospitals, so suppose if you're taking about the Tata Memorial hospitals or any big hospitals, they are maintaining their patient records on a centralized manner. But that particular record is accessible within that hospital only. Suppose if any doctor wants to access the data of that concerned hospital, so it is not possible, right? So everywhere the manual system is there, and even though the digitalized system is there, so that is restricted to the one particular hospital. The main goal for today's session is why we are not thinking for creating the unified ML driven record system, which is accessible from anywhere by both the doctor as well as the patients. Now what are the objective of smart healthcare record system? That we're going to develop a decentralized online health record portal. I'll explain about the decentralized online health record in further slides. That we are going to enable the secure login and data sharing between the patients as well as doctors. That when you think that every patient will get one login, right? So with the help of that login, with the help of that particular ID, that particular patient can show his own history to the concerned doctors. That doctor don't have to worry about that previous what type of previous treatment or the past treatment is given to the particular patient. We are going to use machine learning for predictive analytics for the anomaly detection. We can also use a blockchain for privacy, interpretability, and scalability. So our main focus is how blockchain plays a vital role for maintaining the privacy and interoperability and scalability as far as the medical healthcare record is concerned. These are the main objectives. Now, as we are focusing on blockchain technology, first of all, I'll explain about what is blockchain technology. As we already heard about the databases, as I think the participants are belonging to the tech backgrounds or the science backgrounds, they already aware about the databases. So basically, what it means a databases store the data only, right? So suppose if we can say a student database, if we can say the employee database, if we can say suppose industry database, and so on. But blockchain is an advanced database, we can say. So it is a mechanism that allows the transparent information sharing within the business network. A blockchain database store the records in the blocks that are linked together in a chain. When when we talk stored transaction record, but there is no chain at all. But in case of a blockchain is advanced. We can say it's advanced databases. In blockchain, there is a chain between the blocks. So what is actually a block? In that screen you can see there is a block 1, block 2, block 3, and number of blocks you can create. And what particular information in block gets stored? The block will store the transactions. The block will store the log information about the transactions. The transaction happening into the networks. So every blockchain consists of a block, and in between that there is a chain, so called as blockchain. Right? So while talking about the blockchain, so one particular block is having the number of log records. Suppose block 1 is having the number of log records, block 2 is having the log records, block 3 is also having the log records. And every block is connected to each other. And what is the beauty of this blockchain? When we start creating a blockchain, every block is connected to its previous hash values. Right? If the participants are from tech background, so they knows about the linked list concept in the data structure. In case of a linked list, what happens? Every node is connected with the next node. Right? That means every node is having the address of another node. Right? But in blockchain, there is some reverse thing is there. In blockchain, what happens? In blockchain, every block contains the hash value of the previous block. Right? So when we start up the blockchain, the very first block is not having the previous block. It means that the first block is called as the genesis block. That means it is the starting block of a blockchain. So every first block of a blockchain is called as the genesis block. And after that, every block contains the hash value or the address of the previous block. So now you can see that every block is having a unique hash value, and every block contains the previous hash value. Right? So with the help of that, when we create the blockchain, so every block contains the hash value of the previous block. It means that a chain gets created. Right? Now talking about the blockchain, what happens when the log record get recorded into the blockchain? We are not going to edit it. We are not going to update it. We are not going to modify it because it is. And it's all the data recorded, the transaction get recorded in the blockchain, transparent. Every what we can say every member of the blockchain should know everything happening into the block. There is no hidden thing exist in the blockchain. Everything is transparent. Even though doing the transaction of 1 rupees, that is known to everyone. Yes, I did the transaction of 1 rupees. Right? So that's why nowadays blockchain is very much popular as far as the security is concerned, transparency is concerned, and the privacy is concerned. That's why the people are moving towards the blockchain technologies. Now, what are the main features of the blockchain? So that why the people are using blockchain? The very first and foremost thing is decentralized digital ledger. As we already know about the ledger is just one kind of a node, and we are writing transaction details one by one. Right? Just like in a shop, just go decades back. The shopkeepers generally maintain one register, and in that register they are maintaining the records. Same thing. We are maintaining a decentralized digital ledger. So digital ledger means we are maintaining the ledger in digitalized format. And to decentralize, that means what do you mean by decentralize? There are two terms, centralized and decentralized. Centralized, there is a central authority who can control happening into the particular networks. But decentralized means there is no central authority. That means decentralized. That means there is no central authority. There is no one who is what we can say who is controlling the happenings or who controlling the transactions going into the blockchains. There are blockchain uses a decentralized things. It means that that decentralized, that means everything will be decentralized. There is no centralized platforms. Right? So that's why if something happened with one particular node or something happened with one particular blocks, then other blocks will not be affected. But if we're talking about the decentralization, there is not possible to what we can say to hack any block, to hack any node, or to do something related to what we can say. There is very difficult if the hacker is present or the AI hacker is there, and they are going to breach out your data in the blocks, or we can say in a nodes itself. Second point is secure and tamper resistant. That means once the data get recorded into the blockchain, you are not able to resist it. That means you're not going to change it. It is very much transparent and a tamper proof, right? Enable the transparent record keeping. It is transparent. That means I have already told you, if I do any sort of transactions, the transaction knows to everyone. There is no restrictions at all. If I do one transaction, so my subordinate or my peer don't know what type of transactions I made it. No. If I'm using a public blockchain, so everyone knows everything. It is totally depend on the type of blockchain you're going to use. It depends on that transparency should be maintained actually. Now, why to use a blockchain in healthcare actually? As today's topic is about healthcare, so why we need to use a healthcare? Not just talking about the healthcare records. I talked about electronic record, that is patient record. We are going to create the patient data. We are going to create the patient data decentralization or a digital data or a digital records. When these type of data are moving towards space or traveling on the space or traveling on the wired network or wireless network, there are a lot many intruders are there. There are a lot many thieves are there. There are a lot many AI hackers are there. They are trying to breach out your data. So they are monitoring your records. They are monitoring your activities, and they are trying to breach out your data because we are on the physical space, and it is very difficult. If data are passing on the network, if intruders hack your data and suppose the particular hacker change or particular have changed your data, as you know, the patient data are very much crucial, because if there is a change in a sign, positive or negative, or there is some changes in the values that we got from pathological laboratories, if any hacker or introduce change your data, it will be more impactful on the patients, as well as it is very difficult to the doctors to take appropriate decisions. So we need to prepare such a system with the help of blockchain. We have to prepare a digital data of a particular patient in such a way that whenever that data gets travel onto the network, no one will be able to reach out the data. No one will be able to what we can say reach out the data. No one will be able to hack that particular data. That is our main aim. Ensure the patient data ownership. If we have created a patient data, once the patient visited the hospital, his file created. So instead of creating the file, we are going to create a digitalized record, and that record will get stored into the blockchain in a decentralized manner. So ownership would be there. If I am the patient and I'm moving to my doctors, I'm visiting to the hospitals. So as a patient, I have my own login credentials. So I can share with the doctors with the particular ID. Suppose if I am the patient and if I think if I am suffering with XYZ disease and that data I don't want to share with the doctor because it is very much crucial. Or suppose if I think I don't want to share with anyone else, so I can make some sort of right information on that data. So data ownership is available with the patient. Reduce the fraud and errors, because when sort of a prescription, so there may be possibilities while maintaining the records in manual form. So there may be possibilities. The errors may happen. The fraud may happen. So while using a blockchain, you're going to reduce it. After that, improve interoperability among the system, which is very much important because the system it is system dependent. It means that when we create the things, it will be verified and dynamic that data get recorded into the blockchain. So interoperability there will be exist. Now, what is the role of blockchain in healthcare records? So, how you can say the blockchain plays a vital role in the healthcare? Now, talking about the data security and integrity, as I have already told you, that blockchain is very much secure. With the help of hash, we are not going to change any sort of hash. We are not going to access any sort of data. we are not going to breach out the hash values because it is very much secure, right? It is in the form of decentralized systems. There is no centralized authority. All data are stored, or data are recorded in a decentralized form. Transparency is with the privacy. So when the data it travel on the blockchain, when the logs or the transactions happen, so it is very much transparent. There is no hidden things. Once the transaction is initiated, starting from the initiation till the record storage, till the record get added into the blockchain or in the block itself, it is everything transparent. That every member of this particular chain, that every member of this particular blockchain is know each and everything. Okay? That it means that it will be more transparent with high privacy. Now you can see in the diagram there are number of blocks you can create. Now the question arises in your mind, while traveling the data, while storing the data in the blockchain. So what is the structure of your block actually? That every block is having a header value. Every block contains a previous block address called as a hash value. Every block uses a timestamp. At what time the block get created? Every block is having the nonce value. Basically, nonce means what? While creating the hash value, so nonce is a universe of hash. Then, and I am targeting the one particular space of that particular universe. So I need to access the value for getting the appropriate nonce. So nonce is one of the parameters, and Merkle root. That it is important because we are using the Merkle tree while using the blockchain concepts. Right? So these are the things that is required for creating the blocks in the blockchain. Interoperability, blockchain enables a seamless record sharing across the different hospitals and the clinics. Standardized format ensures the compatibility. Interoperability means what? It is a seamless record sharing. It means that suppose if I am taking the what we can say, if I am taking the treatment from one particular hospital located in Nagpur, and suppose I'm now moving to Bangalore, right? And I need to start start taking the treatment from the doctor located in Bangalore. So in this case, that the particular doctor is in Bangalore, that person can access the data of the particular doctor who has provided the treatment to the patient actually. So that means the sharing of data is there actually, and that in a standardized format, it ensures the compatibility, right? So when we talked about the electronic health records, so that we are creating a system in such a way that particular patient record, particular data can be accessed by any hospital, any clinics all over the worldwide. Next, patient-centric ownership. That the patient has a control who can access their data via smart contracts. That smart contract is one of the major thing while we are using the blockchain. Right? Smart contract is just a contract between the patient and your system. Or not a patient and your system. We can say your system and the members itself. That we need to prepare a smart contract. So based on that smart contract, if the smart contract exists, then and then your transactions happen. Otherwise, it cannot. Just take an example: when vending machine is there, unless if you are not putting some sort of money in that, so we are not getting some sort of items from that particular machine. In many restaurants, you can see many restaurants are getting the vending machines. What we can say in that there are different names as well. It means that suppose if the 10 rupees, I'll put 10 rupees in that machine, and one what we can say, one wafers packet it come out of that machine. So there is a contract between you and the machine. When I'll submit a 10 rupees coin, when I'll provide a 10 rupees coin to the machine will provide the data. Machine will provide the items, right? As per the selection of the user choice. That means a smart contract. It is the contract between the system and the members, right? Now it is auditability. Every access or update is permanently recorded. Once you record the particular transactions, so it means that it is permanently. We don't have an option to change or to update the records. It ensures the accountability for both doctors and the institutions as well. Now, what are the types of blockchain? if we talk about blockchains, there are certain types. One is public blockchain, private blockchain, federated blockchain, and hybrid blockchain. You might have learn about this also, public, private, hybrid, and federated also. Talking about public blockchain is open to all. Anyone can join this blockchain. It is free access. There is no permission at all. There are shared ledger. It means that there are different data are stored in a decentralized platform, and full transparency. There is no access control, or there is no ownership on this particular type of blockchain. Now, talking about a private blockchain. If we talk about a private blockchain, so it is for the closed network. It means that, for example, suppose if I have my own company, if I'm having my own company and I need to take, suppose I want to create a blockchain, I need to create a blockchain for my company only. So I am going to set a private blockchain. So only the member of my own company are going to access the data. Only the member of my company are going to see the transactions. What is going on in the company actually. Whatever transactions are doing by the members, that is known to the member of the companies only. Now, talking about the federated blockchain, so it is group activities. It means that suppose if 2 to 3 financial institutions come together to form a blockchain. If 2 to 3 organizations are coming together to form a blockchain, it means it's federated, right? So that particular blockchain is restricted to the group of organizations, right? So it is not fully what we can say, not private and not public. It is federated. It is multiple organizations involved into that. Now the next one is hybrid blockchain. So talking about the hybrid blockchain, it provides the features of public blockchain and a private blockchain. So it is a combination of public as well as a private. So in this particular blockchain, the what we can say, the member of this particular blockchain, they can think which data we need to take private and which data we need to state as in public. So that is a hybrid platforms. Now, what are the different types of architecture? If we talked about the blockchain, so it focused on the network architecture. As being the tech background, we already known about for server-based network or client-server network. In client-server network, one server exists. That server gets connected with all the clients or all the nodes, and data gets stored on centrally. If central computer got some issues, if there are some issues with the central machines, your whole data get collapsed out. You're not able to access the data, even though you're having the backups, right? Backup is another things. But if we talk about a client-server network or a server-based network, so if problem or the issue occur with the server, so it is very difficult to get back your data, right? Now, talking about a peer-to-peer network where the blockchain actually work. Blockchain work on peer-to-peer network. In peer-to-peer network, every node is connected with each and every machines. It means that if anything happens with one particular machine, all machines are working. But there is no chance to happen something with the particular machine because every machines are connected with each other, and every machine is having some sort of a blocks. So every machine is connected with the help of hash values, right? So there is no chance to breach out the data or to what we can say, to breach the data or to hack the data. So blockchain will be work on peer-to-peer network actually. Now, if blockchain works on peer-to-peer networks, so there are three types of things. So P2P network, structured, unstructured, and hybrid. If we talked about the unstructured network, so in unstructured network, it is very difficult to find the content. Unstructured network, anyone can join your network. Anyone can be the member of your network. There is no structured way, right? In a structured P2P network, there are some policies, there are some softwares, there are some virtual layers exist, which is used to which is responsible for getting the particular node into the blockchains, or we can say that there is a particular structure we need to follow. There are some softwares that we need to follow for creating the network. And hybrid is a combination of a P2P network and a client server architecture. It means that it will hold the client server architecture as well as the peer-to-peer network. Now, cryptographic hash function in the blockchain, it is very important. Now, whenever we talk about the blockchain, the hash function plays a vital role. So basically what it means a hashing, and what is the role of hash function, cryptographic hash function? Suppose if you have any sort of data, that data you want to store it into the blockchain. So for any sort of data, we need to generate a 256-bit hash value with the help of any sort of hashing functions. With the help of any sort of hash algorithm, we can generate a digest for any particular messages. Say for example, if you have a hello words, and that hello is stored into the blocks. What we need to do? First of all, we need to create a 256-bit hash value. And how that hash value will generate? We have a different hash value generator that we can use through the online platform for generating the values. That you can see. For hello, we have generated this hash value, and it is irreversible. We are not going to generate the hello from this hash value. Once you generated this hash value, it is 256-bit hash value. With the help of that hash value, we are not going to generate a hello back. It is irreversible, right? So, and it is deterministic. It means that if we write HELLO, the hash value is this one. But when we write hello in caps, the hash value is different. It is deterministic, right? That we need to keep remember all of these things while generating hash values for a different records. Now, what are the cryptographic hash function? The hash function applies to the message in order to generate the mass digest. That we need to use a hash function. If you have any sort of message, and if you want to generate a digest for that, so what you have to do? We have to apply the hash function. We have to apply the various hash function, like we have a SHA-224, we have a SHA-256, we have a SHA-512, we have a KCAG-256, Whirlpool. Different hash functions, cryptographic hash function is available in online that we can use. These algorithms to generate the hash value for the different messages, right? Now it takes an arbitrary size input as a message. Your message size is arbitrary, right? Your input message and it can be of anything. That message is given to the hash function. Hash function will hash function will generate a digest. The digest is of 224-bit if you are using a SHA-224. If you are using SHA-256, the digest will be of 256. Likewise, the digest gets generated. But the digest is irreversible. Once the digest gets generated for the particular message, for the particular data, that with the help of that digest, we are not going to revert back. We are not getting the data revert back with the help of the digest. That is the main thing with the help of main thing for the cryptographic hash functions. Now, how to generate the hash value for any digest? Now, see, if we talked about a message, your message can be of like your data will be of numeric data. Your data will be of textual data. Suppose if you have a text file. Suppose if you have a image based data. Suppose if you have a video based data. Suppose if you have a audio based data. Your input message can be of any kind, right? Your input message can be of any type. So that message may be numbers, text, image, video, or audio. That message we need to provide it to the cryptographic hash function that I have already talked about. It SHA-512, we have SHA-256, we have a SHA-124. Different hash functions. We have a KCAG, we have a Whirlpool. Different hash function exist. But when we apply this hash function on the given message, it will generate a digest, or it is also called as hash value. So once the hash is generated, right, that hash is used for making the transaction successful, right? And if that digest generated, and with the help of generated digest, we cannot generate the message from this digest or the hash value. Now there are different platforms with the help of we are going to generate the hash values in an online platform where the things are already exist. We can use directly while preparing, while you are going to develop some sort of a project. We can use these websites. We have a free formatter, we have an online web toolkit, we have a text tool suite. These are the different platforms already exist on web that we can use for generating the digest and hash values. Now the second part, how blockchain technology actually works. whether it may be if you're using the blockchain in medical health or in finance or in education purpose or any other things, we should know how actually blockchain works. The very first and foremost thing is the first point, that we need to request for the transactions. Suppose I want to send the money uh, from my pocket to the another one. Just we take the example of Bitcoin and other things as well. I want to do the transactions, right? So first of all, we need to request for the transaction. Second part is a block that represent the transaction is created. We need to create a transaction. First of all, we have to prepare the request. Then we have to prepare a transactions for that particular requested transaction. After that, the next thing is the block is sent to every node in the network. As we already know, blockchain uses a peer-to-peer network. So once a transaction get initiated, a transaction float to all over the network. It means that suppose in my network the 100 nodes are exist. So I need to float these particular transactions to the 100 nodes. And out of that, there are some validators. If we are using a Bitcoin blockchain, we called as miners. And in case of a Ethereum blockchain, we called as validator to validate the transactions. These are the two different terminologies or two different terms. It is totally depend on which type of blockchains we are going to use, whether it is Bitcoin or whether it is Ethereum blockchain. In Ethereum blockchain, the the person who are going to validate your transaction known as a validator. But in case of a Bitcoin blockchain, the person who is going to mine your transactions known as a miners. So it means that the fourth case is we need to validate transactions. If the particular node validate your transactions, then again the transactions get floated over on the network. If 51% voting should be required for validating the transactions, whosoever is validated this particular transactions. It means that if the transaction is validated by XYZ person, then again that transaction is float over on the network. All networks see whether that particular person mined that transaction, validate that transaction properly or not. 51% voting is required. If we'll get the voting more than 51%, it means that that transaction is complete, the transaction get recorded into the block itself. So that is the actual working of blockchain. Now, how it relate with the medical healthcare record system? So suppose if the particular patient prescription is created by the doctor, there are validators are exist in the network. They are going to validate the transactions, record it to the network, validate it, require the votings, and get submitted to the blockchains. Now, while using the transaction process, consensus plays a major role. Basically, what means a consensus mechanism? It is basically protocols that we need to use for verifying the transactions. So basically, consensus mechanism, there are different consensus mechanisms. POW is a proof of work is there, proof of stack is there, POET is there, proof of burn is there, proof of activity is there. There are many consensus mechanism available. It is totally depend on the type of blockchains you are using. According to that, we need to use a consensus mechanism like POW, POS, POET, POBT, and proof of activity as well. So if we talked about the consensus mechanism, the first step is we need to verify the transactions by the verifier. Then verifier broadcast it to the blockchain network. You need to verify the transaction broadcasting, verifier by the other verifiers. If the verifier, that what we can say, the particular transaction get verified by the verifiers, the transaction is added into the block, and block is added into the blockchain, and finally the transaction is finalized, or that your transaction is completed successfully. That 6 steps we need to follow while starting from initiation of the transactions till the transaction get complete. Now, basically, what it means a proof of work, that I'll explain proof of work and proof of stack. There are many consensus mechanisms are exist, but I'll explain about a proof of work and a proof of stack. Basically, what it means a proof of work. Suppose if I am holding the public blockchain, and in public blockchain, suppose if I am having 100 nodes, and I need to initiate the transactions. So what happened with the POW? Once you initiate a transaction, every miner start working to mine the transaction. If the 100 miner is there, every miner start working on it. And you already aware about it. If the miner exists, if the miner is there, so they, for mining the transactions, we required a huge amount of infrastructure, strong hardware we required the high consumptions, or we can say what high electricity consumption is required for this to mine transactions actually. Now talking about a POW, well, transaction initiator, everybody start working on that, right? And out of that, one of the miner get the result to mine the transactions. So till time all miners are working on the same particular transactions, only one miner will get a chance to validate that particular or to mine the transactions. So out of that 99, or what we can say, that all 99 miners are working on the same transaction mining process, their efforts are going to be best, right? So there are lot many things happen for mining the transactions, right? Because the efforts of different miners are going to be best. Only one miner will get the benefit of that. So that is the work of POW. So basically POW we have been used with Bitcoin blockchain, right? Now after sometimes when the Ethereum's come into the picture, the new consensus mechanism was invented called as POS, called as a proof of stake. Basically it was used in the Ethereum. So in POW, all miners are engaging to mine the transactions, to find the hash values, this and that. But in POS, proof of stake, that validators in POS, in Ethereum, the miner term gets changed into validators, right? So validators need to stack out some sort of cryptocurrencies for mining the transactions. So out of that, randomly we can pick up one of them, and that particular validator try to validate the transactions, right? If he validated successfully, he will get some sort of a reward back, right? So these are the different kinds of consensus mechanism that we can use for mining or validating the transaction. It is very much important. Now talking about the POW and POS, just I talked about the miners and the validators, and we require the cryptocurrency and this and that. But when we are making the decentralized healthcare system, we require the miners, we require the validators, but we don't have to put our own cryptocurrency and this and that. Right? We can have a members that they are going to validate the particular records, whether the particular records is really a genuine records or not. And for that particular purpose, we have to take help of machine learning algorithms, that we can use the AI technologies instead of doing the POS and POW. That we need to take the help of machine learning to classify the transactions, whether the particular transaction is belongs to the hospitals, the particular transaction is related to the patients or not. That we need to classify the data, and if data classification is right, so then the data get recorded into the blockchain. So we are going to remove this POS and POW things from a blockchain actually. Instead of that, we are in what we can say, we can introduce this AI and the machine learning things in blockchain. We can integrate these things with the blockchain. Now talking about Hyperledger Fabric. So Hyperledger Fabric, it is the foundation. It is a Linux foundation framework. So basically, Hyperledger Fabric, it is just a framework that is used to form a blockchain, whether it is permission, whether it is non-permissionless blockchain. It is an open source platform. Nowadays, lot many companies have been provided different Hyperledger Fabric, different what we can say, a framework that we can readily used for setting a blockchain for a one particular organizations. That fabric, that platform or a framework that we can use to create the blockchain for a one particular organization. So then when we talked about the hospitals management, when we talked about the healthcare institutions, so we are going to create a framework. We have to use, instead of creating, we have to use a framework for creating the digitalized healthcare record system. So we need to use a particular hyperledger fabric. So it is having some sort of features like controlled access, high performance, low latency, confidential in transactions, and modular architectures. Now there are different hyperledger fabrics available. That Fabric, it is one of the hyperledger framework. Then Suit, it is one of the framework. Indy, it is one of the framework, and Iroha and Besu. These are the different hyperledger framework that we can use. It is provided by the different industry that we can say Fabric. It is the main purpose of Fabric is enterprise private blockchain. It is the key feature is modular channels and chain code. The Sur, it is one of the framework. It is basic purpose. The basic purpose of Sur is modular ledger with POET. POET, it's basically proof of elapsed time. That is what we can say. It is a consensus mechanisms. It is used with Sur. And after that, the main key features are parallel and parallel transaction executions. Likewise, ND, Iroha, Besu. These are the different kinds of hyperledger framework exist that we can use for setting the blockchain for a particular organizations. Now, how Hyperledger Fabric works. If we talked about a framework, or we can say a fabric, right? So there are different types of that. Even though Hyperledger Fabric is exists, so it is also based on the peer-to-peer networks. So when we talked about a peer-to-peer network, so there are different kinds of peers available in the Hyperledger Fabric while setting the peer-to-peer network. We have a endorser peer, we have an anchor peer, we have a general peer. Then what are the roles of these peers actually? Right, your ordering peer. What do you mean by ordering peer? What is peer? What is endorser peer? Basically, endorser peer. The role of endorser peer is to establish the connections. It is create a pull. It is create a bridge for the transactions. I'll explain the second slide actually. Now, if there are endorser peers, the main job of endorser peer is it is responsible for simulating and endorsing the transactions. It ensures the transactions follows by the chain code logic. Now, what is the role of anchor peer? The role of anchor peer is it is acted as a communication bridge between the organizations. It is used for cross-organizational discovery and the gossips. General peer, that it is mentioned in the gray color that you can see. Gray color, that is general peer. Basically, general peer are responsible to store the ledger in the world state. It commits the block and keep the network updated. And your ordering peer, it is mentioned the green color that you can see here. So ordering peer, basically it is not a peer in the normal sense. It orders the transactions and creates a block. Basically the role of ordering peer is to prepare the orders of the transactions and creation of the blocks. Now, what is the workflow? So while working with the Hyperledger Fabric, that workflow need to follow. That client send a proposal. Any client, suppose if you are making the transactions for healthcare, so that suppose if the doctor exists, so doctors need to send the proposals, and also peer simulate transactions. The proposal, whatever transactions prepared, that endorser peer will simulate transactions. Client get an endorsement. Client send an endorsed transactions to the ordering services. Orderer creates the block. Block delivered to the all peers. Peer get validated. Peer validation would be required and ledger updated to everywhere. Once the peer get validated, the ledger get updated and ledger updated for every blocks or for every nodes available in a decentralized manner. Right? So this workflow we need to follow. Now, what are the various use cases of a blockchain in healthcare? There are different use cases in healthcare itself while using the blockchain. The very first one is managing the patient data. Second thing is medical credential and tracking. Just a sec. Sorry for the interruption. Is it audible? Anyone please reply?
Yes.
Okay, alright, thank you. So there are different use cases of a blockchain in healthcare. That one is we are going to use the blockchain for managing the patient data. We will use the use the blockchain for medical credential tracking. There are a lot many happenings will be there in medical research institute, or we can say hospitals. So for that we have to use the things for credential tracking. We can use a smart contract for the insurance, for medical claiming and all. We can use the blockchain. Another is management of the drug supply chain. So for supply chain, drug supply chain, that we can use the blockchain. Then management of medical procedures, that there are different procedures are that to be happen in the medical itself or in the hospital itself. So we have to use the blockchain for managing that medical procedures as well. So there are different use cases that we can use for implementation of the blockchain in the healthcare itself. So basically, this is a workflow for EHR, blockchain based EHR. Now, see, in the physical space, we have a hospitals, we have a patients, and we have a doctors. On physical space, these are the physical entity, hospitals, patients, and doctors. We need to fetch all the data from all of these stakeholders. That data get recorded into the cloud. We have to fetch the data from the cloud for the authentications. Once the authentication happens, that means once we authenticate that particular data is received from from the authenticated person, then it will gives to the ensemble. MA ensemble means it is a multiple attributes ensemble learning classifiers. Basically, here we can use the machine learning algorithms for classification of data, whether that particular data belongs to the healthcare system or not, whether that particular data is related to patient or doctors or not. That we have to use a multiple attributes for assembling classifiers. After the key distribution center, that for every patient we need to create the key distribution center. The role is we need to provide the credential, or we can say IDs to each of the patients. Now, after that, there is again a cloud server, and we're going to store the complete transactions on the cloud server. And after that, the last one is access of services. So it means that the access of services means there is a hospital, patient, and a doctor again. So who are going to access these services? So hospital can access the data of the patient. Patient can gives a right permission to the hospitals or the doctors. The doctor can access the data as well. So on the access of services, that means with the help of mobile phones, we can access the data. With the help of desktop, we can access the data. We can tab. Suppose we can use the tablet for accessing the data. So these are the different devices. With the help of that, the services can be accessed by the different stakeholders. So this is actually the workflow that we can follow while creating the blockchain based EHR. Now, talking about a system architecture and overview, basically this is a core layer architecture. First is data acquisition layer, inputs from the patient and doctor IoT health devices. Then we need to gather the data from the patients, from the doctors, and from the IoT health devices. Right. So what is the role of IoT health devices? Nowadays in the medicals or in the hospitals, IoT devices are exist. So IoT devices are there to sense the various data in an online platform, and that data gets stored on the servers. Right? That's why IoT health devices, it is also the part, or it is also acting as we are going to what we can say that we are going to take the input from the IoT's devices or various devices which are attached to the IoTs. Then after that, storage layer. So we have to use the cloud. We have to use a blockchain-based secure record management. We have to use the cloud because the huge amount of data exists for the medicals or the hospitals. So we need to take the help of cloud for storing the data. ML analytics layer, that is, we have to use a predictive diagnosis, health train analysis, and alert generations. So ML, it is also play the major role in the hospital systems for classification of data, for classification of various image-based data, or for predicting the accurate results in case of, for example, say I'm talking about the diagnosis of the cancer patients or anything else, right? So where do you take the help of the machine learning or artificial intelligence as well, is for the different diagnosis of various diseases. Then access layer with the help of web, mobile, dashboards, that we can use by the patient and doctor. So we have to use the web or mobile dashboards for accessing the services of this particular systems that we can put. Then this is actually the blocks diagram for online health record system. So in the middle one we have a ML analytics layer, that is a machine learning layer. Then we have a data acquisitions layer. So we can acquire the data from the patients, doctors. Then we have a storage layer for storing the data, and there is access layer for accessing the data from the uh, accessing the data to the web or the mobile portals. So we can create a dashboard as well for accessing the data with the help of various devices. Integration of blockchain and the ML, that we are going to integrate the ML in the with the blockchain. So what we can say for getting the better accuracy or for getting the better security, while creating the unified platform, or we can say one platform where the all patient data will be at the distributed manner or a distributed ledger pattern. So as we already know, if we talk about the blockchains, we have a block, we have a ledgers, then we have a distributions. Then you can see in the diagram that there is a transactions that holds the different locks. Then there is a confirmation and proof of work, that we can use the proof of work or proof of stack that we can use. Then again there is a block rewards, that means it is used for our validators and the miners. Those who validate the transaction, they will get a reward points. And we can also integrate the machine learning for mining the data. We can use the different algorithms, we can use the classifications, we can use the neural network or deep learning. We can use different machine learning technologies, machine learning techniques for we are going to integrate with this for creating such a kind of what we can say decentralized EHR systems. Then blockchain application in health. So there are innumerous applications of a blockchain in healthcare that we can use in clinical raw data collections, that we can use the data management. We can have a clinical data repository for accessing the data from the patients as well as for getting the data from the doctors. We have a various research institute, we have a insurance companies, we have a government what we can say government hospitals, we have a different university working on the healthcare, we have a different hospitals. So different things are there that we can use the blockchain concept in a healthcare systems. Now what are the different key features of this? So if we talked about the EHR, electronic healthcare record system, so what my thought process is, we need to create a unified login system where a doctor and a patient can log in, automatic medical records can update it, smart search and a summary using NLP, that we can use the NLP as well. We can use the AI driven health insight and the alerts. We can also use the role based access control and data visualization dashboards. So we can create dashboards as well for visualizing the data. What is the workflow? So we can create the user or a doctor's login, we can have a data upload, that means there is an option we can upload the health records through the what we can say we can upload the health records, we can uh, take the data from the IoTs devices, we can upload the reports, and so we can use the ML engine process data, we can generate the predictions and alerts, we can also generate the predictions. Then last one is result display on the dashboard. So on the user's dashboard, we can display the results as well. And what are the various feature research opportunities for the student and the faculties, that we can use the explainable AI for the healthcare. Right, nowadays explainable AI, it is on a booming stage. We can use the explainable AI for healthcare. We can use HML. Now age is also one of the new concept introduced, right? So that we can use the HML for wearable devices. We can have a smart hospital management system, we can create opportunities for the interdisciplinary research, that persons that what we can say the different peoples come the interdisciplinary background, so they can come together and do the research in healthcare. Then collaboration models like industry, hospitals and research center come together for collaborative research. So these are the different opportunities for the researcher, or that is student and the faculties as well, right? So this is all about from my side. Thank you. So if you have any questions, so please ask me.
It's a very nice presentation, sir.
Thank you.
So I
Thank you.
have a
Thank you.
question.
Just a sec. Hey, just a sec. Yes.
So this is Yavin from PhD at Krishnamurti College, Coimbatore.
Just a sec. Just a sec. I'll see.
Uh, Sir, you said the cloud computing wearable devices in hospital. So I need
What?
some clarification about that, sir.
So your voice is actually
How?
breaking. Uh-huh.
So may I
Yes.
know audible, sir?
Yes, yes, please, please.
So you said the wearable devices can
Mm-hmm.
use in hospital
Yes.
services.
Yeah.
So I need some clarity about that, sir.
Yeah, nowadays many big hospitals they are using the wearable devices. That in the wearable devices they have some sort of a sensors, or we can say that particular things are connected with the IoTs as well, right? So suppose if any doctors are performing any procedure on a particular patients, right? So suppose if the doctor is doing one kind of operations on a one particular patient, and we are having some sort of a wearable device, so that device sends some sort of a information, right? And that information get transferred through the IoT devices onto the clouds. So it means that it is very much clear to everyone whatever procedure is happening with the particular patients, and that information gets sent. So it means that there is no fraud, or there is what we can say, there is that means many times what happens that what the patient relatives or anything else, that they will blame on the doctors, that with the help of that mistake done by the doctor, that's why the patient get died, right? So many times these things are happened, right? So what I'll do, there are some wearable devices. The wearable devices will sense the data, and that data get recorded into the blockchain. So everyone knows what actually what particular doctor has did while during that particular procedure or operations. So that is one kind of things that I have used, that wearable devices that we can use in the hospitals as well for sensing the data. I hope
Thank you, sir.
I clear with the doubts of you.
Sure, sir. Thank you.
Any other else? Any question?
Yes, I think so. The questions are done. So, a very good day to everyone present here. It is my proud privilege to propose the vote of thanks for today's session. First and foremost, I express my sincere gratitude to the management of SRM for their constant support, encouragement, and commitment towards organizing academic programs of this scale. Their vision and encouragement have made this faculty development program possible and successful. I extend my heartfelt thanks to our respected head of the Department of Cybersecurity, Dr. J. Jabamalar Tamilselvi ma'am, for her valuable guidance, motivation, and continuous support in organizing this FDP and ensuring its smooth execution. I would like to convey our deepest appreciation to our esteemed resource person of the day, Dr. Jagdish Pimple, Assistant Professor, St. Vincent Pallotti College of Engineering and Technology, Nagpur, Maharashtra, for delivering such an insightful and informative session. Your expertise and knowledge have greatly enriched our understanding of next generation cybersecurity and ethical hacking, sir. Thank you. I also extend my sincere thanks to all the faculty members and participants for your enthusiastic participation, active involvement, and keen interest, which truly added value to today's session. Special thanks to the organizing team of SKRGC Academy. My special gratitude to the organizing committee and technical team for their dedicated efforts, coordination, and behind the scenes work in making this program a success. Once again, I thank everyone for being a part of this session and contributing to its success. Thank you all.
Thank you, Jeremy. Dear participants, the feedback link will be posted in the WhatsApp group. Kindly fill the feedback for the day 2. Thank you. Thank you, sir.
Yes, thank you so much, organizing team. Thank you, SRM and SKRGS Academy for inviting me. Thank you all the participants for their patience listening. Thank you everyone.
Thank you, sir. Thank you.
Okay, sir, should I leave the meeting?